Hi everyone, I hope all of you are doing good. So today in this video, we are going to discuss how to solve the numerical problems based on the defects of vision. Primarily, we'll be discussing the defects myopia and the hypermetropia. So my dear students, before directly jumping into the numericals, you must be knowing the theory part of the defects, like what exactly these defects are, okay, what are the causes, done, hypermetropia, and how are they corrected. So if you haven't studied that, I'll be providing you the link wherein I have covered both myopia as well as the hypermetropia. Okay, so after watching that video, come here and here you will get the numerical part of this. All right. So as you know that in this video, the objective would be how to solve the numerical problems based on myopia and the hypermetropia. Got it? Now, as you know that, see, what will be our approach? First, I'll be taking the general thing like how to solve the questions. Okay. And then after that, we'll be solving some questions here in this video. And then at the last, I'll be giving you some questions which you can solve at home. Got it? All right. So without any further delay, let us start the session. So numericals on the defects of vision. So what will be the steps? Okay. What will be the steps you will follow? The first step, whenever the question will be in front of you, first you will see that what kind of defect this person is having. All right. Sometimes it will be given in the question itself, and sometimes it won't be given. So when it will not be given, you will have to diagnose it that what kind of defect it is. So for example, the defect which we are talking about is the myopia, right? So this is the first step. Let's suppose the defect which this person is having is the myopia. Then second thing is what changed in the myopia? Is it the far point we change or is it the near point it changed? Okay. So what changed? Exactly, it's the far point, because what happens in myopia? A person can see the nearby objects clearly, but he can't see or she can't see the objects which are very far. Okay. So it's the far point we change. So you will be asked in the questions to find the power of the lens. How can you find the power of the lens? You know power is equal to 1 divided by f. So you need f focal length. How can you get the focal length? You need to know image distance v and you must be knowing the u. Okay, you can use the lens formula and you can get the f, right? So what will be u in this case? That is the object distance. And what will be v in this case? Got it? So let us see. U, what changes in the myopia? It is the far point we change. So you will write far point. Done. Yes. In the object distance, you will write far point, and in the image distance also, you will write far point. Done? Very good. But the object distance, you will write far point of the normal eye. Okay? Of the normal eye. And in case of image distance, you will write far point of myopic eye. Okay? The eye which you are talking about. Got it? Now, in both of these, you will put minus here. Okay, because they will be on the left side, okay, opposite to the direction of the incident rays. So u will be taken as minus, what is the far point of the normal eye? It is infinity, right? And we write it like this, you must be knowing it, infinity. Then what is the far point of the myopic eye? It will be given in the question, right? So minus far point of the myopic eye, whatever. Okay, and then using the lens formula, which is 1 by f equals to 1 by v minus 1 by u. Okay, using this formula you can calculate f, and by f you can calculate power. Got it? Very good. Now see, you don't have to memorize any formula. Like there are books in which there are the formulas given. You don't have to memorize that. Okay, just follow this and you will be able to solve each and every question without memorizing anything. Got it? All right, so let's discuss. Let's suppose some person is suffering from the hypermetropia. I have a question which is given there, and I saw that this person is suffering from the hypermetropia. Okay, now what changes in the hypermetropia? Yes, it is the near point we change. Far point does not change, near point changes. Because in hypermetropia, person cannot see nearby objects clearly. He can see the distant objects very clearly. So U will be taken as V, right, like this. U. So I'm saying that what changes in the hypermetropia? Yes, the near point change. Yes, so we'll write near point here. And we'll write near point here as well. But U stands for the normal eye. So U will be near point of normal eye. Yes, normal eye. And V will be near point of hypermetropic eye. Got it? And both of these will be in minus. So minus, what is the near point of the normal eye? Okay, the least distance, at which a person can see. It's 25 centimeters. So you will write it as minus 25. And V will be minus, it will be given in the question itself. Alright. So by that, U and V, you can calculate F. And if you know F, you can calculate the power. Okay. So now, isn't it easy? Yeah. So now let us see, let's apply this in the questions. Okay. Very good. Question number 1 says, the far point of a myopic person is 80 centimeter. So there is one thing which is clear, that the person is suffering from myopia. So I don't need to diagnose it. It's very clear. And the far point of this very eye, of this myopic eye, is 80 centimeters. Okay, in front of the eye. What is the nature and power of the lens required to correct the problem? See, nature I can get it. If the person is suffering from myopia, we have already studied this. Yes. If the person is suffering from myopia, he would need a concave lens. Okay. So the first part is solved. The nature of the lens would be concave. Okay. But the problem is I need to find the power as well. Like how much power should be there. See, it is a concave lens. It will be having minus power, right? Because focal length is also minus. So minus. So will it be minus 1 diopter? Will it be minus 1.5 diopter? Will it be minus 2 diopter? What will be the power of the lens? Got it? So to calculate that, we will use the procedure, which we studied. First, we will write U and then we will write V. What is U in myopia? Yes. What changes in myopia? Is it the far point which changes or is it the near point which changes? Yes, it is the far point which changes. So U will be taken as far point of the normal eye. And what is the far point of the normal eye? Okay, I will write it for you. Far point of normal eye. And what is the far point of normal eye? It is infinity, yeah? So we will write it as minus infinity as we write. Then V is far point of myopic eye. Yes, this defected eye. And here in this question, it is given as the far point is 80 centimeters. So we will write it as minus 80 centimeters. Okay. You know U, you know V. Can't you calculate F? Yes, you can. So I'll write it like this. 1 by F equals to 1 by V minus 1 by U. Okay. Equals to, what is V equal to? It is equal to 80. So I will write minus 80 here. Minus 1 divided by, what is U equal to? Minus infinity. You write minus or you write plus, it will not matter. Because 1 divided by infinity will be 0. Okay, will be 0. So what remains? 1 divided by F equals to minus 1 divided by 80 centimeters. It is in centimeters, by the way. Okay, done. Take the reciprocal, F will be equal to minus 80 centimeters. Done. So you know the focal length now, it is minus 80 centimeters. Exactly. We are seeing that it's myopia, so it needs concave lens. And the focal length of concave lens is negative. So this answer should be correct. It is in minus. Okay. Now, you need to calculate the power. Power is equal to 1 divided by F, if F is in meters, and 100 divided by F, if we are writing F in centimeters. Yes. Just converting meters into centimeters, nothing else. P is equal to 100 divided by, what's the value of F? Yes, what's the value of F? Minus 80 centimeters. Got it? So 0 and 0 gets cancelled. Yeah. So power will be equal to, either write it as like minus 10 divided by 8 okay, diopter. Or if you want, you can write it like this, minus 1 point, yes, 818, 2 remains, 2 but divided by 8, it's 1 by 4, it's 2.25 diopters. Okay, done. So the power of the lens which is needed to correct this defect will be minus 1.25 diopters. Got it? I hope you understood this question. Then let us move to the next question. Now, question number 2 says, the near point of the hypermetropic eye is 1 meters. Again, the problem is given, the defect is given itself, that the person is suffering from the hypermetropia. Okay, so when the person is suffering from this defect hypermetropia, okay, how can this be corrected? This can be corrected using the convex lens. Okay, this can be corrected using the convex lens. Done. Okay, so this is the nature of the lens, but what is the power of the lens which is required to correct this defect? Okay, let us solve this question also. As I said that no need to memorize any formula. Okay, just remember one thing, that u and v. Okay, what is u? Yes, u is always for the normal eye, and for myopia it is the far point, and in hypermetropia because the near point changes, so it will be minus near point, yes, of normal eye. Got it? And v will be minus near point of hypermetropic. I'll not write it fully now. Okay, hypermetropic eye equals to, now u will be equal to minus what is the near point of the normal eye? It is 25 centimeters. Okay, and what's the near point of this very eye, hypermetropic eye? It is 1 meter. Okay, so I can write 1 meter as 100 centimeters. Okay, so I am writing it as minus 100 centimeters. Got it? Any confusion till this point? Okay, I hope not. Now let's use the lens formula. 1 by f equals to 1 by v minus 1 by u. Yes, equals to 1 divided by, what's the value of v? It is minus 100 centimeters. Minus 1 divided by, what's the value of u? Minus 25 centimeters. Done? Yeah, very good. So 1 divided by f equals to 1 divided by minus 1 divided by 100, minus minus becomes plus, plus 1 divided by 25. Okay, 1 divided by f equals to, what should be the LCM of 125? Very easy, it is 100. Okay, I hope I don't need to explain this at this level. Okay, 100 divided by 100 will be 1, 1 multiplied by minus 1 will be minus 1, plus 100 divided by 25 will be 4. Okay, 4 multiplied by 1 will be 4. Okay, now what now? 1 by f equals to what? 4 minus 1 is 3, so it is 3 divided by 100. Okay, done. Yeah, it's in centimeters, by the way. Yeah, it's in centimeters. So do one thing, take the reciprocal, f will be equal to 100 divided by 3 centimeters. Done? Yes. So this is f equals to 100 divided by 3 centimeters. Now I need to calculate the power. Yes. So power will be equal to 100 divided by f. Okay. 100 divided by, what's f equal to? 100 divided by 3. So when you take 3, it will be in numerator. Yes. 100 got cancelled. Power is equal to, can you see any minus sign here? Yes. No, you can't see the minus because the focal length is plus. Because it's a convex lens, you already know that. So 100 gets cancelled. It remains plus 3 diopters. Okay. Done. So what's the power of the lens which you require? Plus 3 diopters. Plus represents it's the convex lens, and 3 diopters represents the power of the lens which is required. Alright, very good. Now these two questions you will solve, and whatever the answer is, write in the comment box, and let me see how many of you can solve these questions. So question number 3, I'll just read it out for you. Okay. A person cannot see objects clearly beyond 50 centimeters. Now here in this question, it's not written what kind of defect this person has. Okay, it's only saying that a person can see the objects clearly beyond 50 centimeters. 50 centimeters के बाद वो जो है वो objects को अच्छे से देख पा रहा है, उससे पहले नहीं. Find the power of the lens to correct this vision. Okay, to correct the vision. Next question. Now in the next question, it is clearly written the near point of the hypermetropic eye is at 75 centimeters. So you don't need to worry about this. All right. So solve these questions. If you find any difficulty, write in the comment. Okay, I'll try my best to reply. All right. Take very good care of yourself. Bye bye.